Hi and welcome back to my YouTube channel. Have you ever wondered how DC generator works? And what are the basic parts of a DC generator? This video will give you the answers to these questions. We will start with the basic parts of the elementary DC generator. As you can see, the configuration of DC generator is pretty simple. The stator is a fixed part of the DC generator. The stator consists of permanent magnets, two of them north and south poles, which is placed to fit around the rotor. The main function of the stator is to provide the magnetic fields through which the rotor or armature coil is rotated. Armature loop are generally placed in slots of armature core. The armature coil is formed by connecting several loops in the series. Armature winding is formed by connecting several coils in series. The armature loop cuts the magnetic field, due to which an electromotive force, EMF, is induced in it. The split ring is a movable device used for reversing the polarity of the current. It's made of copper. The ring is divided through the middle into two parts. We must use the split ring to achieve single direction of current. The brushes are made of carbon. These are rectangular block-shaped. The only function of these carbon brushes of DC generator is to collect current from commutator segments. A galvanometer is an analog electromechanical actuator that produces a rotary deflection of some type of pointer in response to electric current. So how does the DC generator work? Firstly, we don't want that current direction to change. We want it to remain the same at all times. Let's say in this direction. So, how do we do that? Now, to make sure that the current direction remains the same, what we require is that these brushes constantly keep changing contacts between these wires for each half of rotation. So if the current flows in this way, in this position, this brush must be connected to this wire. So current flows like this and comes out. But when the coil rotates, you can see that when the coil comes to this position, the direction of the current changes. If we want to keep the current in the same direction, we must this brush to be in contact with this wire. Right. And then again, when the coil comes to this position, again the direction of the current changes, and again we want this brush to come in contact with this wire. Probably we already learned that. For every half rotation we must change contacts between brushes and wires. But how do we make this process happen automatically? We can automate this process by adding split rings. Split rings, as the name suggests, is a ring that is split in between, giving two half rings with the same gap in between. Now let's see how the split rings automatically change contact for every half a rotation. So right now this brush is in contact with this half part of the split ring, violet color. When the coil rotates and comes to this position, the direction of the current changes, and this brush now is in contact with the other half part of the split ring, pink color. This arrangement provides that current flows in the same direction. Again, as the coil comes to this position, finishing another half a rotation, you can see that this is only changed contact. Brush is in contact again with the violet color half part of split ring. In this way, the DC generator is built, where the current only flows in one direction through any external circuit, and in this arrangement, with brushes and split rings, which helps us to automatically change contacts, we call them commutators. So split rings act like commutators. The next thing we must mention, that it's really important for working principle of DC generator, is how can we determine the direction of the current, magnetic field and force. To determine all this, we must use Fleming's right-hand rule. So we will explain how can we use Fleming's right-hand rule. As you can see, the rotation of the coil is clockwise, and the force acting on part of the coil AB pushing that part of the coil upwards. So to know the direction of the induced current, we apply the Fleming's right-hand rule. How do we do that? We place our right hand so that the thumb points up, showing the direction of the force. The index finger or the finger pointing in direction of the magnetic field from north to south pole, and middle finger will point in the direction of the induced current, which is in our case from A to B. Similarly, to find the induced current in a part of the coil CD, we again use Fleming's right-hand rule. So the rotation of the coil is clockwise, and the force acting on part of the coil CD pushing that part of the coil downwards. The thumb points down, indicating the direction of the force. indexed finger, or for the finger pointing in direction of the magnetic field from north to south, and the middle finger will point in the direction of the induced current, which is in this case from C to D. So to conclude, the induced current follows the path ABCD of the coil. The effect of the split ring commutator in DC generators is to ensure that the induced EMF is always in one direction. We can see that in this graph, where V represents the amount of induced EMF and T represents time. You will notice in the graph how the sine wave changes with rotational speed of the coil. The coil in this case has clockwise rotation. Increased rotational speed of the coil increases the amount of induced EMF. The induced EMF has a positive sign. Also, you see the example how the sine wave changes with rotational speed of the coil, when the coil is rotating counterclockwise. Again, the increased rotational speed of the coil increases the amount of induced EMF. In this case, the induced EMF has a negative sign. To conclude, the DC generator has many advantages like the design is simple to operate, highly reliable, constant voltage can be achieved, speed control is easy. Also, DC generators are added in many applications like boosters in welding equipment to charge batteries and solar systems in an emergency at your house and offices. I hope that you now know everything about DC generators. Don't forget to subscribe, like and share this video. Watch the rest of my videos on my YouTube channel. Please consider to support me on Patreon. Thanks very much. See you on the next video.